Kia ora, ko Brady Perry tōku ingoa. This is my TEACH211 assignment 1, thinking like a science teacher. For this assignment, I've chosen to focus on materials at year 2. The practice I'm focusing on is applying knowledge of the properties of common materials, such as wood, metal, plastic, glass, rock, paper, rubber, and cardboard. More specifically, the practice focuses on students sorting and grouping materials based on how they behave physically, with a focus on their mechanical properties and using simple comparisons. In this presentation, I'll explain the key science concepts connected to this practice before introducing a learning experience that I would use to develop this learning in a year 1 and 2 classroom. There are a few key science concepts that I'll need to understand as a teacher before teaching this practice. Firstly, is material is the substance that an object is made from. It is important that students understand the difference between an object and its material. For example, a spoon is an object, but that spoon could be made from metal, plastic, or wood. The next concept is physical properties. These are characteristics of a material that we can observe or test, such as whether something is hard or soft, rough or smooth, or flexible or rigid. Mechanical properties are more specifically about how a material behaves when a force is applied to it. The science curriculum explains that materials behave differently when they are pushed, pulled, or twisted. For example, flexible materials can bend, while elastic materials can stretch or bend and then return to their original shape. The final concept is sorting and grouping. Students use the properties they've observed to identify similarities between materials and then use this evidence to decide how they could be grouped. The general capability I've chosen to connect with this learning experience is communication. Te Mataiaho explains that capabilities are embedded within and across the knowledge and practices of learning areas. Communication includes actively listening, participating, and expressing information appropriately. This links strongly to my learning experience because the students won't just handle and sort the materials. They'll need to communicate what they observe and explain their decisions to others and the teacher. The capability and literacy examples resource also specifically says that in science from years 0 to 3, students describe their observations in the world around them using appropriate scientific vocabulary. So in this activity, students will be developing that capability using words such as hard, soft, flexible, rigid, rough, smooth to describe what they are observing. The learning experience I've designed is called Material Detectives. I think it'll be a good lesson, not only because the students will enjoy thinking they're little Sherlock Holmes running around with little magnifying glasses. I know my students will do that. But learning intentions for students to identify, compare, and group common materials based on their properties. The success criteria would be that students can identify different common materials, describe how a material behaves, compare the properties of different materials, sort the materials into groups based on their properties, and explain why they've grouped certain materials together. This activity follows a simple process of observe, test, compare, sort, and explain. I think it's appropriate for year 1 and 2 learners because it's pretty hands-on. It doesn't rely heavily on reading or writing. So that students, if they do struggle in reading or writing, they won't be left behind by this while they're working on their science. For equipment for this activity, each small group would receive a tray containing a range of common and familiar materials. This could include a wooden block, like a Jenga block or spoon, a metal spoon, plastic container, rubber band, paper, cardboard, a rock, and a piece of fabric. I'd also provide simple property cards showing words such as hard, soft, flexible, and rigid, along with sorting mats or hoops. I've deliberately chosen everyday materials that students are likely to recognize and that are easy and safe for young students to handle. Each group would receive a similar set so that all students would have the opportunity to investigate the same range of properties. Before beginning the activity, I'd first establish students' prior knowledge to see what they already know. I'd show them some everyday objects and ask questions like, what is this made from? Or how could you describe this material? This would help me identify what vocabulary and ideas they already understand. I'd also explicitly introduce or revisit important words such as hard, soft, flexible, rigid, rough, and smooth. In terms of preparation, I would organize identical sets of materials and make sure the differences in their properties are clear enough for our young students to recognize. Safety also obviously needs to be considered. I wouldn't give students real glass or anything with sharp edges, and I'll check all of the objects before the lesson. An initial question, such as how could we describe and group these materials, would also give me some quick formative assessment information before the main investigation begins. The first step is introducing material properties. As a teacher, I would show students several of the materials and model how we can observe and safely test them. For example, I might compare cardboard and a wooden block. I can demonstrate that the cardboard can bend quite easily, while the wooden block is much more rigid. I'd introduce the property pairs shown on the slide, such as hard and soft, flexible and rigid, and rough and smooth, and strong and weak. Rather than simply telling students the answer, I would use questions like, what do you notice? How are these different? And what happens when I try to bend this? This modelling is, I think, particularly important for Year 1 and 2 students because it gives them the language and process they will need when they begin investigating for themselves. The second step is the main hands-on investigation. Working in small groups, students will observe and safely test for different materials on their tray. They might feel the surface, gently bend something, press it, or compare it directly with another material. They then use the vocabulary from our introduction to describe what they're noticing. Students will compare the materials and begin sorting them based on shared properties. For example, they might place materials that bend together and materials that remain rigid together. An important part of this activity is that there isn't necessarily only one correct way to group everything. The focus is on whether students can use an observed property to justify their decision. I would circulate between the groups and ask questions like, why have you put those together? Or what did you observe that made you decide that? This keeps the focus on using evidence rather than just guessing. Because this exercise is designed for a Year 1 and 2 class, I didn't want it to be the recording component to become a writing worksheet. I would print out the table that's shown on my slide here. On the left is all the materials that we've tested, and then there will be some columns. And in the columns, they'll put, if they think something's hard or soft, they'll put the starting initial for that. This way, as I mentioned earlier, for students that struggle with reading or writing, it won't slow them down, as it's a pretty basic concept, which helps keep the focus on science rather than reading or writing. There are also several things I'll need to consider when facilitating the activity. For differentiation, I could use pictures alongside the vocabulary, model each property clearly, and pair students strategically so they can discuss their thinking. One misconception I would watch for is students confusing an object with a material. For example, saying spoon is a material instead of recognizing that the spoon is made from metal. Students might also assume that a material can only have one property. I would reinforce that something can be both hard and smooth, for example. Another consideration is that some properties are relative. Something might seem flexible compared with wood, but rigid compared with rubber. My role throughout the investigation would therefore be to observe, question, and prompt students rather than immediately telling them whether their classifications are correct. Because it's a Year 1 and 2 classroom, my assessment will be mainly formative. Rather than expecting students to complete a large written task, I would gather evidence through observation, questioning, and conversations during the investigation. I would look for whether students can correctly describe a property, sort materials according to that property, or make a simple comparison and give a reason for the decision. A simple final assessment could involve giving a student 2 materials and asking what is the same or different about these. The student could answer verbally, point, demonstrate, or physically sort the materials. as long as I understand what they understand. This directly returns to the science practice because students are applying their knowledge of common materials through sorting, grouping, and making simple comparisons. The curriculum itself identifies comparing and grouping everyday materials based on shared physical properties as part of the Phase 1 learning. It also continues to develop communication because students are sharing their observation using scientific vocabulary. To finish up, I think this activity would give students a practical way to develop their understanding of materials and their properties, rather than only being told that materials have different properties. They have the opportunity to observe, test, compare, sort, and explain for themselves. The three main resources I've used to support my planning are the draft science curriculum, the New Zealand curriculum, Te Mata Aiaho, and the capability and literacy examples by learning area resource. Together, these helped me connect with science knowledge and practice with an age appropriate learning experience and with communication capability.